So after you've looked at them and written the equation, then you're going to say what type of function is it. Then you're going to complete the table. The table up here is a little incomplete. I think you have more room on yours. For my table up here, this says f of n. I'm going to write a g of n next to it. And I'll do like a tri-column table when we go over it together. And then I want you to make, it says 1 to 2, I'm going to make you make 2 observations. Make 2 observations about your outputs for the 2 functions that you're given from your patterns. And this will take, I think, 7 minutes or so. We're ready. There's some groups that didn't quite finish, but it's cool if they were working toward it the whole time, because the thing that those groups got stuck on, in a moment they're going to go, oh, like I know you know it. So, the equation that represents pattern A, I got n squared. It's the number of the steps squared, so let's, is that quadratic or exponential?
Quadratic.
Does it ask for an equation? Okay, sorry, my bad, y equals. So that's quadratic. How do I know it's quadratic? That's square. Right, those second differences keep coming up. All these things have had squares. That tells me quadratic. So, 0 squared is 0. 1 squared, 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 49. 64. Okay. I'm going to do a different color for G. G of n. So, for the equation here, what's happening over and over? Double. So the number 1 wrong answer I've seen today is 2n. That's repeated addition of 2. This isn't 2 more, 2 more, 2 more, 2 more. This is doubling. This is 2 to the n. Or, you may have written it as an initial value of 1. It's doubling to the n power. These are both the same. This is an exponential function. So if I went around and I said, you're overthinking it, you see what I'm saying? Now you're like, oh, I've definitely seen that. Since our class average was like 90-something on that quiz. Right? So I know you know it. Is this quadratic or exponential? Exponential. Okay. 2 to the 0 is? 1. That's the other spot I saw the most wrong answers, even though they gave you a 1 there. But anything to the 0 power is 1. 2 to the first? 2. Then we got 4, 8, 16, 32, 64, 128, 256. Now we're to the point where we're going to make some observations. Who can tell me things that they notice about the inputs, outputs here? What's something you notice? Ivy.
So like for the f of n, in order, like I just found like when I was filling it out, it's easy, like in order to get the next number, I looked at like the step number, but for the g, then I had to look at the previous.
The previous versus the step?
Yeah.
That is true, yeah. The step numbers are harder relation to ship to just follow because it's in the exponent, right? So you have to look at the previous and doubling. I like how you said that. Okay, another observation that's out there. Brendan.
Pattern E goes faster.
You think so? So let's do a little, I'm going to put a little plus sign by the thing that's bigger. Bigger, okay, I see you. Bigger. Equal. Bigger. Equal. Bigger, bigger, bigger. So I don't know if we can make that general of a statement, Brendan, which is an observation I'm making. Like if we would explain what's growing faster, we would say g of n, then f of n,
After step number 5.
and then g of n for reals, right? Why is that?
I would say after step 5 would probably always be g of n.
That's interesting. I want you to start thinking about why. We're going to examine another pattern to see if it holds true. But usually it's like something's lower, they meet up, and then it's higher if they cross, right? Like when we've seen systems, when we've seen exponential functions, usually like once the thing takes off, it's either one or the other. This one, bigger, smaller, bigger, or smaller, bigger, smaller, depending which one you're talking about. So I want you to start thinking about why this might be true as we look at the next pattern, okay? So the next pattern, instead of having images, you're just going to get the function. And I'm going to suggest, you don't have to, that you do a 3-column table. That's my suggestion. I like this for comparing, if we're going to be comparing things. but you can do whatever you need to do. So we're going to look at 6x squared and 3 to the x and see how things change. Okay, again, we're going to make those, explain how it changes as the input increases. This should take, I think, 5 to 10 minutes with your partner. Also, a reminder that there is a thing called the order of operations. So, 3, 2, 1. Eyes on the board, mouths closed. So remember last time, I think the exponential was bigger, smaller than bigger forever? Let's see what happens this time. So, I'm going to use 0, 1, 2, 3, 4, 5, 6 for inputs. And you're going to help me input it to p of x. So when I put in 0, what's 0 squared?
0.
Times 6?
6.
0. When I put in 1, 1 squared is? 1. Times 6? 6. I put in 2. 2 squared is? 4. Times 6? Anybody get 144 there? It's all right if you did. I know some people have all day.
7, 8, 4, 4.
Someone got 144?
Oh, no.
Okay. I'm going to put 3 in. 3 squared is? 9 times 6? 54. Where to put 4 in? 4 squared is? 16. Times 6? 96. Put a 5 in. 5 squared? 25. Times 6? 150. 6 squared is 36. Times 6 is 216. Is that right?
My partner and I actually went 1, 2, 5.
You 216, you had to do that square and then
You had to square it.
You had to do the square first.
You got to square it first and then multiply by 6. That's why I said make sure you think about the order of operations. Because it's tempting to do 6 times the input and then square that. 6x squared does not equal 6x squared.
I made a silly mistake.
Okay. Hey, Brandon, that's your 1. I might have already given you 1, but I don't remember. Okay. Q of x. This one is just tripling, right? So 3 to the 0, everybody. 1. 3 to the first. Times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243. Times 3 is 729.
So the 20th is 3, 4, 8,
So-
6, 7, 8, 4, 4.
Did you guys vibe with that plus sign, equal sign thing I was doing? I kind of like that. I didn't do that first hour, but I kind of vibed with it. So, let's put plus signs by the things that are bigger. So, first round goes to
P,
Q of x. Second round,
P,
P of x. Third round,
P,
fourth round. Fifth round,
P,
sixth round.
Q,
Woo!
Q.
Last round. So let's talk about why. Do you guys remember that warm-up from today with the 10 squareds and the 9? Okay? So the things that have the exponent that, like we're doubling or tripling, if we give it more time, what ends up happening? Huge, right? The impact is bigger and bigger. With a quadratic, what's our exponent every time? The 2, right? So if our exponent's 2 every time, it doesn't have that chance to get those bigger and bigger and bigger and bigger to that same scale of jumps, right? Right here, it's getting squared every time, which is still like big. Here, at some point, we're tripling something big. That's why here it takes off. Now, why does this one start bigger though?
because you already have the 6 there.
The reason is does an exponential function ever go through the origin? No, why not, Caleb?
Oh, I don't know. Oh, well, 3 to the power of 0 would be
1. Where here, if we get a 0 in there, what happens when we multiply by 0? 0. Over here, when we get, and then any exponent to a 0 leaves me with, you can't get smaller than, well, you can't with like fraction days, but it never even would go through the origin ever if it's exponential, right? We approach 0, or we get it closer and closer forever, but it's never 0, right? We've seen that question on a bunch of stuff. Wasn't it just on homework? Like, will the price of the bike or whatever it is ever be 0? Is that? Yeah. Like, theoretically never 0, but it's not worth a penny at some point. Yeah, so that's why. It has to start with something when this quadratic starts with nothing, because that can go through the origin. But then up here, Man, once it takes off, look out. It's triple, triple, triple. This is always squared. So it makes sense, right? Bigger, then it switches, and then it switches. But will it ever switch again down here? Forever, it's going to be triple, triple, triple. All right.